XRF is X-ray fluorescent. It is a non-destructive analytical technique to determine the composition of element. So how it works? Electron from one of the orbiter in the surface atom knock out when the sample bombarded with high energy beam and leave a hole. In order for the atom to stabilize and restore its equilibrium, electron from higher energy level will fall to lower energy level to fill the hole. And the excess energy released as fluorescent. The energy released different for different type of element. The X-ray produced will give a different reading depending on what element exists. In the final process, we can determine the type of element exists in the sample. There are two forms of XRF, which is energy dispersive and wavelength dispersive. The advantages for XRF is real total concentration are obtained for elements in silicates. The second one is it is fast and cost effectiveness. We can obtain the result within 1 to 2 days. The last one is versatile. It can be used to analyze a wide range material for most of element in periodic table. As for the disadvantages, the first one is quantitation limitation. Its quantitation limit are 10 to 20 ppm. It restricted for element heavier than fluorine. It cannot determine beryllium. The last one is it must be routinely calibrated. Thank you.
Hi, my name is Muhammad Daniel and I'm going to explain about X-ray diffraction instrument. So the purpose of this instrument is to determine what is the structure that makes up the crystalline material. So there are three key components of the instrument, which are X-ray source, sample holder and detector. So how does it work? At first, the sample is bombarded continuously with X-ray at different angle to trace which plane is parallel to the surface. Then when the conditions satisfy Bragg's law, the moving detector will detect a peak, which is constructive interference is happening, signing that the sample diffracted the X-ray. When the theta value is obtained, we could assume what is the structure that makes up the solid. So there are advantages of this instrument, which are rapid and powerful to identify mineral, and it requires only small amount of sample, and it is straightforward and widely available. So the disadvantage of this instrument is only solid is allowed and the sample should be in purest form, and it requires standard. Thank you. That's all from me.
The technique of X-ray photoelectron spectroscopy (XPS) is also known as electron spectroscopy for chemical analysis (ESCA). This technique was developed by Kai Sieben in the 1960s based on Einstein's idea about the photoelectric effect. XPS is surface-sensitive spectroscopy technique that can analyze a sample to a depth of 2 to 5 nanometer and often used to investigate the elemental compositions of a probe as well as their chemical state. In practice, typical laboratory-scale X-ray sources, XPS detect all elements with an atomic number of 3 and above. This means it can easily detect hydrogen or helium, because the diameter of this orbital is so small, reducing the catch probability to almost zero. XPS is conducted in ultra-high vacuum (UHV) conditions in order to remove absorbed gases from the sample and absorptions of contaminants of the sample. UHV conditions also needed to prevent arcing and high voltage breakdown, as well as to increase the mean free path for electrons, ions, and also photons. Irradiating a sample with sufficient energy of X-ray will result of electrons in specific bound states to be excited. This sufficient energy is input to break the photoelectron away from the nuclear attraction force of an element, bring the results of electrons are ejected out of the atom. Photons with higher energy penetrate deeper into the sample. Identifications of the elements in the sample can be made directly from the kinetic energy of the photoelectrons, and their relative concentrations of elements can be determined from the photoelectron intensities. For the identifications of XPS peaks, the plot has a characteristic peak for each element found in the surface of the sample. There are tables with kinetic energy and binding energy already assigned to each element.
Next, you move on to the Next instrument, which is PIXE. PIXE is particle-induced X-ray emission or proton-induced X-ray emission. It is an analysis technique that uses X-ray emission induced by accelerated charged particles or bombarded particles. The charged particles are usually protons or other ions. In PIXE, we identify the elements based on their X-ray emission spectra. Each element has its own unique set of X-ray emission lines, allowing us to fingerprint them. PIXE is sensitive to elements in the range of natrium to uranium. The light elements are determined by their K-series X-rays, while heavy elements are determined by their L-series X-rays. If the electron is ejected from the ground state, an electron from a higher orbital will fill the vacancy that was created. For a K-series transition, the transitioning electron is screened from the full nuclear charge due to the remaining electron in the ground state. There are advantages and disadvantages of PIXE. The advantages will be the possibility of simultaneously using the information carried by nuclear reaction products, including the scattered projectile particles, and hence extending its analytical capability also to elements lighter than sulfur. And the disadvantage of PIXE is it is lack of precision of critical system parameter. Thank you.